Okay, in this video I want to talk about problems 31 and 32. And here we have other examples of evaluating limits graphically. In the first example we were given graphs and we just had to analyze the graphs to evaluate the limits. In the second type of problem we were given graphs and we needed to find the intervals on which the limits exist. In the third type of graph we were given a piecewise function and we had to come up with the graph and then to analyze the graph. And finally, we're just given some basic properties of a graph, and based on those properties we have to draw the graph. And well, we're just going to draw the graph. This is looking at limits from another perspective, drawing a graph that has certain features. So let's look at number 31. First of all, we know that f of 0 is undefined. It's undefined. There might be a point discontinuity there. There might be a vertical asymptote there. So there may be basically one of those two types of behaviors, but we really don't know. So let's look at the next thing. We know that the limit as x approaches 0 is 4, but the value at 4 is undefined. So that means we're going to have the same behavior from the left and the right coming into where x is equal to 0, and that's going to approach y equals 4. But because the function is not defined there, we'll just start with an open circle. We know that f of 2 is equal to 6. And so we can draw that point in there. And we know that the limit as x approaches 2 is 3. So that means that we're going to have at x equals 3 the same behavior from the left and the right heading into y equals 3 when x is equal to 2. And so I think we can at least draw one piece of the graph in. So now our graph has satisfied the first criteria, f of 0 is undefined. The second criteria, that the limit as x approaches 0 is 4. So we only have it from the left. Now we can continue it to the only have it from the right. Now we can continue to the left. And it could be any graph going off to the left. You can be as creative as you'd like to be there. So at this point we satisfy f of 0 is undefined. The limit as x approaches 0 of f of x is 4, and f of 2 is 6, and the limit as x approaches 2 of f of x is 3. So we just need to continue over to the right, and that should do it. And there are a number of different ways that you could draw a graph that satisfies these conditions, but this is one way. Alright, I'll take a look at number 32 here. What I usually like to do is to draw in any points that I know. So I know that f of negative 2 is 0 and f of 2 is 0. So I draw those 2 points, excuse me. So I draw those 2 points in, and then next I'm looking for the limit as x approaches negative 2 will be 0. So that means I'm going to have the same behavior from the left and the right as x approaches negative 2, and the y value that both sides are approaching is 0. The only other thing we know is that the limit at x approaches 2 doesn't exist. So I could choose to do that in a number of ways. I could have unbounded behavior there, or I could have differing behavior from the left and the right. It might just be easiest for me to try differing behavior from the left and the right. So I'll continue my one line right on into x equals 2, y equals 0, and in order for the limit not to exist there, I just need to have a jump there or have differing behavior from the left and the right. Now because this is a function, I can't have one x value having two y values, so I have to put an open circle there up at y equals 2 when x is 2, and then just continuing the graph off to the right. So this is a graph that satisfies the criteria f of negative 2 is 0, f of 2 is 0. The limit as x approaches negative 2 of f of x is 0, and the limit as x approaches 2 of f of x doesn't exist. So these are some examples of graphs that we can draw, and there are many different graphs that would satisfy these criteria, so you should come up with one or more of your own, and again be as creative as you would like to satisfy those. And that's it for this problem set.